All right, let's dive into one of the most fundamental forces in the entire universe. It's completely invisible, but it powers just about everything in our modern world. Today, we're going to peel back the curtain on electromagnetism.
Our story actually kicks off in a junkyard, and it starts with a mystery. I mean, look at this crane. It can lift these massive chunks of metal, move them around, and then just let them go. But there's no claw, no hook, nothing. So what's the deal? How is it doing that? This is the puzzle we're going to solve together.
Okay, so to crack this case, we need our first big clue: electric current. Now, we can't actually see the tiny electric charges zipping through a wire, but we can measure their flow. And that's all an electric current really is, just a continuous stream of these charges moving from one spot to another.
Trying to track every single one of those little charges, it would be absolutely impossible. So instead, what we do is we just measure the overall flow, the current. It's kind of like traffic on the highway, right? We measure its speed. We don't try to follow every single car. It's just a much more useful way to look at it.
So what happens when we run some of that current through a plain old wire? Well, this is where things get really fascinating. Check this out. With the current off, all the little compasses do what they're supposed to. They point north. But the second you turn that current on, bam, the needles all snap into a perfect circle around the wire. That moving electricity is creating an invisible force field, a magnetic field. And that powerful relationship has a name: electromagnetism. It's this fundamental dance between electricity and magnetism. The crucial thing to get here is that whenever you have moving electric charges, an electric current, you get a magnetic field. They're basically two sides of the same coin.
Okay, so a wire with current flowing through it is a magnet. Got it. But let's be honest, the magnetic field around one little wire is pretty weak. I mean, it can move a compass needle, sure, but you're not going to lift a car with it. So the big question is, how do we pump up the volume on this thing and make it strong enough for some real heavy lifting?
Well, it turns out there's a pretty simple three-step recipe. First, you loop the wire into a coil. It's called a solenoid, and that concentrates the magnetic field. Second, you just add more loops. See, each loop contributes its own bit of magnetism, so they all add up to make the whole thing stronger. And then for the final, most dramatic boost, you slide in an iron core. That just amplifies the magnetic field like crazy.
But it's not just about the shape. The amount of electricity you're pushing through matters a lot. With a current of, say, 0.8 amps, this electromagnet might pick up a few paper clips. But if you crank that current up to 2.7 amps, suddenly it can lift these much heavier metal washers. More current simply equals more magnetic force.
The number of loops makes a huge difference too. So an electromagnet with 30 loops might still only be strong enough for paper clips, but if you double those loops to 60, keeping the current exactly the same, it now has the strength to pick up those same heavy washers. It's like every single loop adds another layer of muscle. And just like that, with those simple steps, we've officially built our mystery-solving tool, an electromagnet. At the end of the day, it's just a coil of wire wrapped around an iron core. It's a magnet that we can build, that we can control, and that we can make stronger or weaker. And that control, that is the real superpower of an electromagnet. I mean, think about a regular magnet on your fridge. It's always on, right? And its strength is fixed. But an electromagnet is adjustable. We can change its strength by changing the current, and most importantly, we can turn it completely on and off just by flipping a switch.
And with that, the junkyard crane mystery is solved. That big disc is just a massive, super powerful electromagnet. The operator flips a switch, sends a huge current flowing through it, the magnetic force turns on, and it grabs all that scrap metal. They move it over, flip the switch again, the current stops, the magnetic field vanishes, and the metal just drops. It really is that simple.
But hold on a second. This story doesn't end there. We've seen really clearly that a flow of electricity creates a magnetic field. But what about the other way around? Could a magnetic field actually create a flow of electricity?
The answer is a resounding, world-changing yes, and it's called electromagnetic induction. Now here's the key. A changing magnetic field is what forces the electric charges in a wire to start moving, and that creates a current. This isn't just some neat little trick. This is how we generate nearly all of the electricity for the entire planet.
And just like with making an electromagnet, the number of wire loops is absolutely key. Watch what happens here. If you move a magnet through 10 loops, you might generate about 40 microamps of current, okay? Double it to 20 loops, and the current more than doubles to 90. Go all the way to 30 loops, and you're getting 140 microamps.
More loops exposed to that changing magnetic field means a much stronger current.
So, if you ever want to generate more electricity through induction, you've basically got three main levers you can pull. You can move the magnet faster, you can use a stronger magnet, or, you guessed it, you can add more loops to your coil.
So how does this incredible two-way street between electricity and magnetism actually apply in the real world? Well, the applications are pretty amazing, and they take us from those industrial cranes all the way to modern cures. I mean, just take a look at an MRI machine. At its heart, it's just an incredibly powerful, incredibly controllable electromagnet. It generates this massive magnetic field inside the tube, and that field interacts with the atoms in your body, allowing the machine to create these stunningly detailed 3D images of our organs and tissues, all without a single cut. It's the exact same principle as the junkyard crane, but instead of lifting metal, it's being used to save lives.
So we started with a really simple question about a crane, and we ended up literally inside the human brain. This invisible force, electromagnetism, is a fundamental part of our universe that we've actually learned how to command. It lets us do the heavy lifting, and it lets us see the impossibly small. It really makes you wonder, doesn't it? What will we command it to do next?